Present good morning students. You are very eager to listen to chemistry class, am I right? Okay, shall we start the class? So the last class what we studied, do you remember? Yeah, sublimation techniques, isn't it? We studied about sublimation techniques. For the few days we are discussing about how the mixtures can be separated. There are two mixtures are there, isn't it? Homogeneous and heterogeneous. First we have started on how to separate the mixtures, that is heterogeneous mixtures. The last class we studied about sublimation. Today we are going to see solvent extraction method. What method? Today we are going to see about solvent extraction method. This method also comes under heterogeneous. It also comes under where? Heterogeneous. This is also the technique used to separate. This is also the technique used to separate the heterogeneous mixture. Okay. Sublimation, what type of mixture we separated? Do you remember? Solid from solid, isn't it? What's the example we studied? Ammonium chloride and you remember sand, isn't it? Today we are going to see how to separate liquid from liquid. How to separate liquid from liquid. So, solvent extraction method that comes under what type? Heterogeneous mixture. And what type of mixture is separated? It is used to separate liquid from liquid. Two types of liquids we studied on today. One is what? Miscible. The next one is immiscible. So two types of mixtures are there. One is miscible and one is immiscible. Both are liquid from liquid, liquid from liquid. But also when we combine one liquid with other means either it forms miscible or it forms what? Immiscible mixtures. What is miscible? Do you remember? Yeah, miscible means what? The solution with a blend with each other. That is two liquids that soluble with each other. For example, milk in water, ink in water are the examples for what type of liquids? Miscible liquids. What is immiscible? The two liquids that does not soluble with each other. Okay, that does not blend with each other. Such a type of liquids are called as what? Immiscible liquids. Today we are going to separate the immiscible liquids by the help of what technique? Solvent extraction. Okay. So once again I am saying when the liquid from liquid forms two types of mixtures. One is miscible and next one is immiscible. Miscible means what? Which dissolve with each other. For example, ink in water. If you add a drop of ink in water, ink dissolves in the water, isn't it? So it comes under what type of mixture? Homogeneous. Okay, and it can be separated by the technique called as what? Fractional distillation. Immiscible liquid means the two liquids, for example, oil in water, kerosene in water, that does not dissolve with each other. That does not dissolve with each other. Okay, such type of liquids we can separate by using the technique called as what? Solvent extraction. Okay, now we can see what is solvent extraction. This solvent extraction can be done with the help of the apparatus called as separating funnel. Solvent extraction technique is done by using the apparatus. Okay, a glassware called as separating funnel. Okay, so solvent extraction method is done with the help of the apparatus name called as separating funnel. It is a glassware used to separate immiscible liquids. The separating funnel which is used to separate what type of liquids? Immiscible liquids. So now we can see the diagrammatic representation of separating funnel, how it looks. Okay. So see. This is the outline for separating funnel. Okay, with the help of this glassware only we are going to separate immiscible liquids. Okay, today for example we can take oil and water. So for example today we are going to separate what? Oil and water. Unfortunately oil mixed with water means we know oil does not dissolve with water completely. At the same time you cannot separate oil physically, isn't it? So by the we can see oil droplets that found above the surface of the seawater, isn't it? These two solutions, they does not dissolve with each other. So this type of solution we can call it as what liquid? Immiscible liquid. Today we are going to separate oil and water with the help of what method? Solvent extraction method. With the help of the apparatus separating funnel. This is the outline of the separating funnel. Both the sides opening will be there. In separating funnel, both the sides opening there, and here it is closed with the stop cock. It is closed with the cotton plug or anything. Here opening is there for the outlet of the water, or for the outlet of the samples. Okay, so both sides open and it is closed. Both the sides are closed. Okay, this is the stop cock for the exit of the sample, Okay, now half of the bulged portion. Okay, so the half, about 75% of this apparatus was filled with the sample. What the sample we have taken? Oil and water. About 75% of this bulged portion was filled with what? Oil and water. Okay, and take it in an inverted portion. What is our slanting portion? What is the slanting portion? For example, see, this is the water bottle, isn't it? See, this is the bulged portion. Here one opening. Just imagine upper portion also the opening is there. For adding sample through this hole, we will take this stopper. We will remove the stopper, and through this we will pour the sample. Oil and water will be poured through this. Okay, and separated through this. Have you understood? Okay, through the upper opening we are adding the sample. At that time it was closed, and after separation we are separating the solution through this samples. Okay, so you can imagine this water bottle. Okay, here one opening, here one stopper, here one hole, just to put one hole or something is there. Through this we are what? 75% of the apparatus was filled with what? Sample, that is oil and water. Okay, and take this. Imagine this separating funnel in a slanting or this position. Okay, in a slanting position, and shake this tube, this apparatus for more than 10 or 15 minutes. Did you understood? Okay, imagine this is what? Separating funnel. Both the side opening is there. Half of the bottle was filled with what? Oil and water. Then just take this separating funnel like this. Stopper at one hand and the separating funnel and shake this like this. Okay, in this landing position, shake this apparatus for more than 10 to 15 minutes. Okay, more than 10 to 15 minutes. You shake this apparatus continuously. Okay, after 15 minutes, you hang this separating funnel in a, you clamp it. Okay, you clamp this funnel. Okay, undisturbed, and keep it for undisturbed. Okay, have you understood what I am saying? So, apparatus 75% be filled with oil and water. Then take it in a slanting position like this. More than 10 to 15 minutes. Shake it well continuously with the severe force. You continuously shake it for 15 minutes. After shaking, keep it or clamp it on the stand without disturbing. Okay. After a few minutes, you can see it forms two phases. It forms how many phases? Two phases. We studied already. Homogeneous mixture, it has single phase. Heterogeneous mixture may show two or more phases. Okay. So here only how many samples are there? Only two samples are there. What are they? Oil and water. Okay. So we will get how many phases? Two phases. Okay. So after few minutes, what you can see? You can see two phases, and at the middle you can see a ring-like structure. Okay, you can see the ring-like structure which separates oil and water separately. It separates water and oil separately. So here this is oil. This is oil and this is water. So the principle behind the separation is based on the density. Based on what? The principle behind the separation is based on the density. High density particles will come first, followed by the lighter particles. Okay, high density particles come first and followed by the lighter particles. Okay, if not only two mixtures, two liquids. More than 2 or 3 mix, you can form 2 or more rings. Okay, 2 or more rings here, and based on the density, each one will get separated in the separating funnel. Did you understood? So after a few minutes, after shaking, clamp it on the stand and keep it undisturbed. After few minutes, you can see two phases, a ring-like structure that is separate what? Water and oil. Here, water is high density particles than that of the oil. So which one comes first? Water followed by oil. Okay, it is not only applicable for two liquids, more than two or more immiscible liquids can be also separated by this technique based on their difference in solubility. Based on their difference in solubility. Based on their difference in solubility and also based on their density, they will separate one by one. Okay. After separating, slowly open this top cork and take what will come outside first. This is the high density here, water, isn't it? Until the water reaches the stop cork. Okay. When the water reaches the stop cork, you close it. Then it was followed by water. So in a beaker, first you collect water. After it was followed by oil. Okay. So collect it in the separate beaker. Now what is separated? Water separately. Water is in the beaker and the separating funnel oil. Based on the density, the two immiscible liquids are separated by using what? Separating funnel. This is called as what method? Solvent extraction method based on separating funnel. Okay. Have you understood? Okay. So this technique is employed to separate two immiscible liquids. That is two liquids that does not soluble with each other can be separated by what technique? A separating funnel. Okay, this is the apparatus, and the home also you can do. Okay, with the help of this bottle. Okay, you can do. Take a white bottle. This is the colored one. You take the white bottles and add some kerosene for better. Oil and water, it will take much time for separation. You take kerosene and water. Half of the bottle you fill it with and shake it continuously for more than 15 or 20 minutes. Here means it is 10 to 15 minutes enough. In bottle more than 15 or 20 minutes it is needed, and keep it undisturbed. You can see two layers. Okay, and using this opening lips like what? Put us after separation, put a small hole and you can separate both the kerosene and water. Okay, did you understood? Okay, so this is the technique employed for separating heterogeneous mixtures. Okay, next a small technique also we can see today, that is called as centrifugation. So this centrifugation, next technique what we are going to learn is centrifugation. Centrifugation. Okay, this is also the technique which is used for separation of colloidal solution. It is used for the separation of colloidal solution. See, what is this colloidal solution? The next class we are going to see briefly about what this solution, that is types of solutions. In that we will study briefly. Before that, today just as I will say the outline, colloidal solution. When we mix two or more components, isn't it, to form a mixture, different types of mixtures are formed. Okay, or different types of solutions are formed. One is true solution, one is true solution. Next one is colloidal, the last one is suspension. So, while dissolving the components with each other, they can form true solution, they can form colloidal solution, they can form suspension. True solution means, for example, salt in water. Okay, that is the example is salt in water. Salt in water is an example for true solution. Colloidal solution, see, milk in water. Milk in water is the best example for what solution? Colloidal solution. Blood is an example for colloidal solution. Suspension, sand in water. Sand in water. Here, the solid particles cannot be seen. At the same time, it is uniformly distributed, isn't it? Here, the solid particles, okay, the sand never gets dissolved in water. They form sediment. They form what? Sediment. Here, in the colloidal solution, so many solid particles are dissolved in liquid that are not completely soluble. At the same time, they never get sediment. They never get a sediment. Such particles, for example, clay water, isn't it? Clay water also after long time it will get settled down. But here, colloidal solution, the blood, the components present in the blood, it will take much time to settle down. Okay, that type of solutions are called colloidal solution. That is solid particles that never dissolve completely. At the same time, they never get sedimented down. Such particles, such solutions are called as colloidal solution. Did you understand what is colloidal solution? Say rice water is also example for colloidal solutions. Okay, so these solutions, the particles, the solid particles that present in the liquid. Okay, they never get soluble. At the same time, they never get sediment. Okay, they form a colloidal nature. That is called as what solution? Colloidal solution. So such a type of solution, how we can separate the solids that it does not completely dissolve or that it does not get sediment. How we can, and also we cannot get filtered. How we can separate? By using the technique called as centrifugation. By using the technique called as what? Centrifugation. So this is the technique which is used to separate colloidal solution, or you can say to separate insoluble solids from liquid. Insoluble solids from liquid. So this is the technique used for separating what type of solution? Colloidal solution. Colloidal means what? The small solid particles that does not dissolve. At the same time, they does not get sedimented. So that is insoluble solids from liquid. That are very small solid particles. Okay, very smaller in size and they does not dissolve in the liquid. Such components or such mixtures can be separated by the technique called centrifugation. And centrifugation is done with the help of the apparatus called the centrifuge. How this process is done? Centrifugation is done by the apparatus that is employed for this technique is centrifuge. Did you see the centrifuge anywhere? See, if you go to the laboratory or the hospital, most of the hospitals, what is attached? Laboratory is attached. If you have the chance means, you just ask, okay, there, what is centrifuge? Okay, all the laboratories, what will be there? Centrifuge. Okay, centrifuge is very important for separating the components from the blood samples. Okay. Okay, centrifuge where you can see in the laboratories, okay, in the laboratories, hospitals, everywhere. In the laboratory, what will be there? Centrifuge, okay, and it is mainly used there to separate the components from the blood sample, urine samples, etc. So, if you have get the chance, okay, you can see. So it is the centrifugation is done with the help of what? Centrifuge. Okay. With the help of centrifuge, the small insoluble solid particles can be settled down. Okay. And how the particle is settled down means based on the shape of the solids, based on the shape, size, density, and viscosity. Based on the size, shape, density and viscosity, the solid particles, the insoluble solid particles get settled down with the help of what machine? Centrifuge. Okay. So centrifugation is done with the help of the apparatus called as centrifuge. Centrifuge is commonly employed for the separation of components from blood as well as urine samples. And what is the principle behind the centrifuge? According to what principle the solid comes settled down is based on their shape, size, density and viscosity, each solid particles get what gets separated on the centrifuge. Okay. In the centrifuge machine, see, so many rotors are there, sockets, okay, sockets, or you can call it as rotors, okay, and small buckets will be attached. Small buckets will be attached. Okay, so many small sockets. Test tube, did you see test tubes? Okay, it is glass, made up of glass, like that. In the machine, in the centrifuge machine, inside the machine. Okay, inside the machine, it has so many sockets. It has so many sockets. Okay, are fitted with rotors. it is attached to these rotors. So many sockets are there. So many sockets are there. Inside the sockets, they will keep the sample. For example, if you want to separate so many insoluble solids from the blood, means if you are giving blood sample, they will take the blood and they will keep inside the test tube. Okay, in the test tube they will take the sample and this test tube is inserted inside the socket, inside the socket, and then it will spin. Okay, they will subject it to spin, that means spin. Okay, spinning will happen. Okay, it will rotate at very high speed. Okay, when we switch on the machine and we have to set up the RPM. We have to set up the RPM. What is this RPM? Means revolution per minute. How many times the socket is rotating per minute, that we have to set up based on the components. Okay, or for example, red blood cells, white blood cells, plasma. What are the components present in the blood and at what speed? Based on their size, shape, density, we have to set up the revolution for 10 minutes, 15 minutes. Then based on that, each particles will settle down on the test tubes. Okay, well, so after taking the sample, this test tube should be kept inside the socket. Okay, and switch on the machine and for 10 minutes, 15 minutes, you set up the RPM. RPM means what? Number of revolutions per minute. How many times it should rotate, for how many times it should rotate for a minute. That we should set up the machine. Okay, and close the apparatus. So while spinning, it is radially outwards. What means? So it does not rotate like this, just it in this position. If the test tube is like this, what happens? If the test tube is like this, each test tubes are hold like this in the sockets. Since it's while rotating, it will be going this radial position. It will go in radial position and rotate very fast. From this position, it is radial outwards. Okay, like this, slanting, and it rotates at very high speed. Okay, very high speed. And the force acting on the centrifuge is called the centrifugal force. What force? It is while spinning. What force is regulated is centrifugal force. The force produced inside the machine is called centrifugal force. Okay, which radiated outwards. Okay, which make the test tube to radiated outwards and spun or it spin at very high speeds. While spinning, based on the size, shape, density and viscosity, all the particles will be separated in the test tube. For example, like this. High density particles will settle down here, followed by the next one, like that. Each one will get separated based on the density, viscosity and shape. Okay, so based on this principle only, the washing machine at our homes is worked out. Okay, so what is the force acting on the washing machine? Is centrifugal force, which is Q's. While running in the radial direction, it is Q's out the water from the laundries. Okay, so once again, first technique what we studied, solvent extraction. Now we have studied about what? Centrifugation. It is used for separating colloidal solution. Colloidal solution means what? Insoluble solids present in the liquid that cannot be dissolved, at the same time they cannot be sedimented. So it is done with the help of the machine, centrifuge. So commonly the centrifuge is used in the laboratory for separating components from the blood. Okay, and what is the principle behind how they are get separated? Means based on shape, size, density and viscosity. Okay, so this is the setup. Here it has sockets. Inside the socket, whatever sample we want to separate, we have to get inside the sockets and it is spun in high speed. Okay, it is spun in high speed. Okay, that is called as RPM. While spinning, what force is created? Centrifugal force. So the test tube that rotates in the radial direction. While rotating, each components, the insoluble particles, slowly get settled down based on their size, shape. They will get separated on the test tube. So based on this only, what is working at home? Washing machine is working, and also cream from milk can be also separated by this technique. Cream from milk also can be separated by this techniques. Okay, so did you understood? So two techniques we have studied. One is solvent extraction, next one is centrifugation. If you want means the diagram, you can clearly see in your book, page number 108. These are the sockets. Inside the socket we have to put the test tubes. While running from this position, it will go on this. Okay, in the radial direction it will rotate. Okay, it will. So students, you have booklet with you, so you can mark some questions. Whatever I am marking, just to take down there. Okay, Already we have studied sublimation on 2-mark questions. And one more questions today we can mark it. That is Roman number 6, fifth one. That is how the homogeneous solutions are different from heterogeneous solution. Explain with examples. Okay. Now I am giving the answer for you. What you have to do means take your booklet and write this question on your booklet as a difference between. Like a difference between, you make 2 columns. The answer is on page number 118 from here to this. Okay, page number 116. Page number 116 here. Homogeneous and heterogeneous mixture. Mark it from here to here. And here so many examples are there. 1 or 2 examples are enough. Just you write this question like a difference between. Make a column, 2 columns, homogeneous, heterogeneous, and make 3 points will be there. First point, a mixture in which components can be seen separately is called homogeneous mixture. Here, a mixture in which the components can be seen separately is called heterogeneous. This make it as a first point. Second point, it has uniform combustion. Here you should write it does not have uniform combustion. There, every part of the mixture has same property. This side, every part of the mixture does not have same property. So, 3 points you got it, isn't it? Fourth point, write some example. Water, milk, ice cream, etc. Here also you write some points. So, you will get 4 points each. Okay. So, this is like assignment. You write this question. Like also elements and compound. Already I have given that question also. You write it in your booklet like a difference between. Thank you so much.